Okay, so far we've created a box plot for this variable in this data frame. Um, Looking at the box plot, I see that we have two outliers here, and I'd like to identify those outliers. So what I need to do is I need to set up a boundary for which any value above that boundary is an outlier, any value below that boundary is not an outlier. Now, in order to do that, I have to find the interquartile range for this data set because outliers are further than 1.5 times the interquartile range above the third quartile. So this right edge of the box in the box plot, if I go 1.5 times the interquartile range above that, I'll find a boundary line that separates outliers. So I need to know what the interquartile range is, so I'm going to add a code cell, and I'm going to use on the data frame called df, I'm going to use the describe function. So I'm going to type df, which is a pandas data frame, dot describe. So describe method, and I open and close parentheses. df.describe is going to give me the count, which is the number of values in the data frame's variable, the mean of those values, that's the mean, the standard deviation of those values, and here it gives me the 5-number summary: the minimum, the first quartile, the median, the third quartile, and the maximum. In order to calculate the interquartile range, I need the third quartile and the second quartile. So I'm going to add another code cell here, and I'm going to calculate the IQR, interquartile range, and I'm going to let that equal 84 minus 70 here. And where I'm getting that from is the third quartile is 84 and the first quartile is 70. So the interquartile range is the third quartile minus the first quartile. So that's the IQR. Once I found the interquartile range, I'm then just going to find the fence. I'll call it fence, which is going to separate the outliers from the non-outliers. So the fence is going to be the third quartile, which is 84, and then it's going to be plus 1.5 times the interquartile range. So that's 1.5 multiplied by the IQR. So that's the fence that I'm setting up. And now in order to separate my outliers, I'm going to create a separate data frame, and I'm going to call that data frame outliers. And in order to create that data frame, I'm going to take the original data frame df, and I'm going to take only the parts of df where that variable is greater than my fence. So I df and I open up a bracket, then I say the specific parts of df are where df, open up another bracket, and then open up a quotation so I can put the variable. Well, the only variable in df is called variable. The only variable in the data frame is actually called variable. So variable, it was there already, variable. And I want variable to be greater than the fence for the outliers. So if the variable in the data frame is greater than the value of the fence, then I want to put that into the outliers data frame. So this is the code that I'm going to run. First I calculate the interquartile range, then I set up a fence, then I take the outliers to be only those values in the data frame where the variable is greater than the fence. And when I run it, it created this outliers data frame. I forgot to look at what the data frame looks like, so I'm going to add another code cell here where I'm going to look at outliers, and I'm going to look at the head of this data frame. Head, open and close a parenthesis, and now it should give me the head of the data frame. There's only two values in my outliers, and they are the 126th value, which is 111, and the 246th value, which is 110. These are my two outliers. These are the two values that are further than 1.5 times the interquartile range from the third quartile, which is the number 84.